record. Let me just share this one right here. And we have here this one, okay? These are the problems we were trying yesterday. Let me just select one of these before, for instance, this one, F, just to review what happened yesterday. So you have the integral dx over x square root of 5x squared minus 3, okay? So we have now to check this one. You can see here the integral, and we can check, we have to check where, let me just put the camera, okay, yeah, like that. What formula may be useful. So we can get this again, and then in the formula chart, you can see here, yeah, you can see the formulas. So we have a quotient, but we have a radical, so we have to go down. And we have these two with radicals, and the formula, our problem has a variable outside the radical. This formula has the variable inside the radical, no outside. So this is the one we're going to use. So we have the integral, yeah, the integral from is u square root of u squared minus a squared, right? Equals 1 over a, the arc secant absolute value of u over a. So this is the formula we're going to use, correct? Now, what is the point here? Well, we have to match these two the best way possible. So, well, the dx, the du looks like this is going to be like this, right? So whatever is inside the root is inside this root here. So we're going to do simply u equals x. That's the first thing. We compare these two. But also we have this one that u is equals, u squared is 5x squared. So let me just put the most difficult, u squared equals 5x squared. Then a squared equals 3. You see? So this one with this one, right? So with these two, we have that the u is a square root of 5x, and the a is a square root of 3. So from this one, dx, du is derivative of this is a square root of 5 times dx. So here we are going to have to adjust this constant here at the top. So my integral, let me just begin. My integral right here is going to be, I need the square root of 5. Okay, I square root of 5 dx. I put it at the top. Then at the bottom, I have an x. I have the square root of, well, I'm going to put here a square root of 5 times x squared, yeah, minus the square root of 3 squared. So this is exactly the same as this one. If you square these two, you get that one. And well, the situation is this: when u is a square root of 5x, here I have the x. So I need the square root of 5. Well, I put the square root of 5. And I see that these two are going to cancel. So I have no problem with my integral. So this is going to be simply the integral of du, because all this is du right here, over u is all this, square root of 5x. Then I have the square root of u squared minus the square root of 3 squared. So that's the change I'm going to do. And if I see my solution, so the only I have to do is, okay, this is equals, I'm going to put here equals, right? I'm going to put my calculus, is 1 over a is 1 over square root of 3, 5, I mean, arc secant of absolute value of u over the square root of 5 plus my constant. So that's my solution. And the only I have to do is, okay, I need just to set back the u. So this is going to be 1 over a square root of 5, the arc secant of Absolute value of the square root of this one is absolute value of the square root of 5x over the square root of 5, correct, plus c. Now, it's obvious that the absolute value of the square root of 5 is 5. So this is going to be simplified very simple. It's going to be 1 over square root of 5. The arcsecant of x only, because these two are going to cancel, right? Plus c. So that's my answer, correct? So check again how is the procedure. So you receive a problem, then you look for a formula that pretty much match. Then you have to make this match perfectly. So you begin pairing term by term. Is okay. U squared is this one. So U squared is 5x squared. Then the U square root is the square root of 5x. A squared is 3. A equals square root of 3. Then from this one, you get the du. Du is the derivative of 5 square root of x, square root of x of 5 over times x, so it's the square root of 5 dx. And then you adjust these constants in your integral. So, okay, you need the square root of x, square root of 5 with the dx. So you put it here. Then you put here this as the square root of 5x squared, which is the same as this. Then the square root of 3 squared. And then here, this is okay, because u is a square root of 5x. Well, I'm going to put the square root of 5 to make the u. So these square roots of 5 cancels. They are perfectly well matching each other. So I change this du, u squared minus square root of 3. Then I see how my formula works. I put here my answer, right? And then I substitute my x back and make any simplification necessary. So you see, integration is also very methodic, okay? So let's do now one of the definite integrals we have in the last section. So let me just share this right here. And right here we have, in the last part, we have these things, correct? You see these integrals, okay. It's not a big deal, it's pretty much the same, except that you have to pay attention to the limits of integration, these ones right here. Okay, so let me just write my first integral. This integral is a square root of 3 over 2. Yeah, 1/2 6 over the square root of 1 minus x squared dx. So this is my integral. So, okay, I wrote this one on my board. And well, I'm going to check which one of the formulas can help me. So again, I go back to my formula chart and I check, well, I have a square root at the bottom. So I have this with a square root. So I'm going to match this then. So it's integral, yeah, of the u over the square root of a squared minus u squared. And this is the arc sign of u over a plus c. Okay, right here. So here is now our matching, you see clearly. Now, well, the 6 is not a problem. You can move the constants out of the integral, so the 6 is no problem. So we check, okay, we match these two. So there is no way out. So is u is the x and the a equals 1. Correct? Because u squared is x squared, so u is x. So in this case, du equals dx. And here comes the only thing you have to really be aware. So you have to change the limits of integration. So in this case, there is no problem because when x is a square root of 3 over 2, right? Let me just put this one. A square root of 3 over 2. The u is going to be also a square root of 3 over 2 because they are the same. So when the x is 1/2, the u is also 1/2. In this case, there is no change because the variable change is the same. So the only I have to do is, okay, let me just write my integral. So is the integral from 1/2 to a square root of 3 over 2. The 6 outside, right? I move the 6 out, and then I have dx over So I'm going to have a square root of 1 squared minus x squared. So this is 1 squared to match this one. And then this is going to be simply 6 times the integral. Okay, the u are the same, so the u values are the same, so I'm going to put them, then I'm going to have du over 1 squared minus u squared du. Okay, now I just put my answer. My answer is the arc sine of u over a, in this case is 1, plus c, right? And the only I have to do is substitute back my value, so it's a. This is the point, not the c. We have to evaluate this from 1/2 to a square root of 3 over 2. This is the only thing. If you have limits of integration, then you have to find, then you have to evaluate your antiderivative in these limits. So this is going to be the arc sine of a square root of 3 over 2 minus the arc sine of 1/2. Now, this is the point I have to remember. From what angle sine gives you a square root of 3 over 2, and from what angle sine gives you 1/2. Okay, technically you should know these values because that's pre-calculus stuff. But if you don't, here is the table in your formula booklet. So you see, what value of what angle gives you sine 1/2 is 1/2, this one is pi over 6, and a square root of 3 over 2 is pi over 3. So this is going to be simply pi over 3 minus pi over 6, right? Then this is 1/3 minus 1/6, pi over 6. So now the integrals having limits of integration are going to be specific values. So the answer is going to be a number, not a function plus a c as we had before. We're going to use this formula because we know the antiderivative. But once you have the antiderivative, you have to evaluate in the limits of integration. The antiderivative in the first value minus the antiderivative in the second one. And then, well, you have to do the operations to get your number. Okay? So everything goes here the same until this portion, right? Everything the same. Obviously, this section of the change of the limits is important because if you don't change them, you're going to get a different number. In this case, no problem because u and x are the same. No questions? It's pretty easy. Okay. Let me just now go to the next problem. The next problem is this one. This is going to be pretty much, yeah, a little bit different, right? So it's going to be the integral from 0 to a square root of 3 over 4 dx over 1 plus 16x squared. Okay, so I have my integral here. You see the integral over there. Yep. And well, I need to find a formula to help me solve this problem. So I go to my formula booklet again. So here is. So you see this one right here is going to be pretty much fine, you see? So it's integral du over u squared plus a squared is 1 over a, the arctangent of u over a. Okay? So I'm going to use this formula, okay? This formula, this problem match pretty much this formula, so I'm going to try to match the value. So I just go one by one. So this is my constant, so my constant match the a squared, so, well, a squared equals 1. And this one match this one, so is u squared equals 16x squared, correct? Now, what I'm going to do is, well, a equals 1, a square root. The u equals a square root of 16 is 4, and the square root of x is x, right? Yeah. So, I'm going to take the positive only, not the negative. I know that this is plus minus, but I'm going to do the positive, correct? Because these values are positive. Okie dokie, well, with this one, du equals derivative of this 4, derivative of 4x4 times the dx. Now, here comes the change. When dx is a square root of 3 over 4, the u is 4 times x. You see, 4 times x, so the square root of 3 over 4. So the u is the square root of 3. The 4's cancels. Then when the x equals 0, u equals 4 times 0, so that's a 0. So these are the new limits of integration, you see? 0 square root of 3. So what we are going to do is, okay, we are going to write this in this format. So we have the integral from 0 to a square root of 3 over 4. So this is dx, this is 4 dx. Remember, I need a 4. So I write here a 1 4 outside. Then you have 4x squared plus 1 squared. So what I did is very simple, is write my problem in the format of my solution, right? So we have this. So this is exactly the same as this one. This force cancels, so it's the same formula. Then what I'm going to do only is, okay, this is going to be 1/4 the integral. Now, from 0, this limit of integration, and now, because I'm going to change to du, so I'm going to put here u squared plus 1 squared. Now, I'm going to put here values of u because I changed the variable already. So the u is the square root of 3 at the top, the square root of 3. Okay? It's very important. Check. They are different now. The 0 is the same, but this is not the same. Okay? Now, I put the answer. This is the answer. So I have 1/4 times the 1 over a. So 1 over a is 1 over 1, right? The arc tangent of u over 1 evaluated from 0 to square root of 3. Okay? Well, I have to do my algebra. My algebra is no problem. So I have 1/4 parentheses the arc tangent of a square root of 3 minus the arc tangent of 0. So the antiderivative evaluated here minus the antiderivative evaluated here. Now, I have to remember what angle has tangent equals the square root of 3 and what angle has tangent equals 0. So again, values that you should remember, but if you don't, okay, remember, here is your partner, here, your formula booklet. So tangent is 0 for 0 and is the square root of 3 for pi over 3. Okay, so this is 1/4 pi over 3 minus 0, correct? And the only I have to do now is, let me just put this one fine. 4 times 3 is 12, so it's pi over 12. That is my answer. Okay, as you see, I'm not doing anything different as in the first part. Just the only thing I have to do is convert the limits of integration to new values of u. And then once I have matched my formula, I have to do exactly the same, match my formula, then this one, then the antiderivative is going to be evaluated in the new limits of integration, not in the old ones. Then you have your answer. Okay, obviously you have to remember some trigonometry to do this. Okay, So the procedure is going to be pretty much the same. So the next problem is going to have the same procedure. So let me just take now check the assignment. And well, I have this or this one. So we have to select one of these. So let me just do one of these. Let me just do this one. These are going to be pretty much the same, right? Yeah, in this case. Oh, let me just do D, because looks like trigonometric functions give you trouble. Yep. So I have integral from 0 to pi over 2 of sine x over 1 plus cosine square x dx, right? So here is my, just put this straight right here, okay? So this is my integral, and I need to find a formula. So again, if you go to your formula booklet, it's okay, which one has a square plus something in the denominator is this one, is the arctangent. So I'm going to use that one. So this is the integral of du over is a squared plus u squared equals 1 over a arctangent of u over a, correct? So that is my formula to use. Okay, well, let's match the thing. So let's begin here. So I have a constant, this is a constant. I have this one, so it's matching this one. So I have the u equals cosine x, or u squared equals cosine squared x, so u equals cosine x. So you square root both sides. Then the a equals 1. A squared is 1, so a equals 1. Now, according with this one, from here I have du equals derivative of cosine negative sine times dx. So the differential of this is the derivative of this times dx. Okay, now let's see. I have sine x dx right here, so I don't have only to worry too much because this is a negative. But I have here 0 and pi over 2, so I have this is when the x is 0, yeah, u is cosine of 0, correct? So x is 0, so you put here an x0, so the u is going to be cosine of 0. And cosine of 0 is a 1. Then when the x is pi over 2, the u is cosine of pi over 2, right? So what is cosine of pi over 2? Well, you remember your trigonometry, that's a 0. Okay, so this limit 0, pi over 2 change from 1 through 0. So I have to be aware of it. So let me just write my integral properly. So this is going to be negative the integral 0 pi over 2 negative sine x dx. So minus the differential. So I put this together over 1 squared plus parenthesis cosine of x squared. This is the same, correct? Now I'm going to do my u substitution. So I'm going to move this with this. So I have, this is going to be the integral negative. Now the 0, when the x is 0, the u is 1. So I'm going to put here a 1. And when the x is pi over 2, the u is 0. So I'm going to put here a 0. And then I'm going to have negative is going to be du over, because all this is du, remember? All this is du, so I'm going to change this by du. And this is 1 squared plus u squared. Now this is ready to go. Now I have 1 over a, well, 1 over 1, so it's 1, so it's the arc tangent of u over 1, so this is a u, evaluated negative from 1 through 0. Okay, you can do this, or you can flip the signs with this negative from 0 to 1. No problem, you're going to get the same answer. So this is negative the arc tangent of 0. Now, let me just put it right here. Equals negative the arc tangent of 0 minus the arc tangent of 1. So I have to remember what is the arctangent of 0. Okay. Again, magic table right here. Yeah. Right here I have the tangent of 0 is 0, and the tangent of 1 is pi over 4. So minus 0 minus pi over 4. And then this number is going to be pi over 4. Okay. Okay, and again, yeah, this is the final answer. Now again, the procedure, you have your integral, then you try to match a formula. Yeah, pretty much, do match term by term. You determine who's your u, who's your a. Once you have your u, get the du. Once you have the du, because you have limits of integration right here, so you change them using the, you change this one, and then you get new values for u. You group conveniently your integral, and then your u substitution, your answer according with your formula, and then you evaluate in the limits of integration, and then you get your answer. So pretty much the same repetitive thing. Okay. Any question here? Pretty much easy. Okay, let me just do one more. So I'm going to go here. Let me just do, we can select any of them. Pretty much all of them are going to be the same once matching the formula. So let me just do this one to review completing the square again, just in case was not clear. So this one is going to be the integral from 1 to 3, the x over x squared minus 2x plus 5. Okay. Okie dokie, let me just go here. Okay, we have this one. This is my integral now. I have to solve this one, and again, I look in my formula booklet. It's okay, I have. Well, I have this one, du over u. So, and then the only thing I have is this one right here at the bottom, because the other ones have square root. So I have two. So I have integral du over u equals ln. And the other one is the integral from du over a squared or u squared minus plus a squared equals 1 over a, the arctangent, u over a. Correct? So those are my two possible formulas. Now let's see the first one. This is the u. If I make this all the u, the derivative is 2x minus 2. And I have a problem because here at the top I have no x's. So, well, this is not going to work. Now let me see this one. So I have now x squared minus 2x has to match this one. This is, well, I have the square of a constant plus the variable, so I need to write this one. So I need to get x squared minus 2x plus 5 as something like x squared plus something squared, here an x and no x here. So here I have to have an x and this one. Now, how to do this one, right, is remembering your algebra 1. Remember, a squared plus 2ab plus b squared equals a plus b squared. So the perfect squares or the binomial square. Now you are going to match this one. It's okay. I want to write this as this one here. So I have to match the x with the a, the 2 with the 2, the x with the a, and then how much has to be the b? This is, well, let me just write it. X squared with the x, 2x times 1, right? Plus b squared. Well, if the b is like this matching, so it's 1 squared plus 5. And because I add a 1 and I don't have to change my expression, I have to subtract the 1 square. So 1 square minus 1 square is 0, so I have exactly the same expression. It's extremely important that you get this always equal, correct? So these three are going to be expressed as this formula. So you have x plus, no, it's minus here, minus, it's minus 1. In this case, let me just put the minus, the corresponding minus, minus plus, this is minus, this is the same formula, square plus, here you have 5 minus 1, 4, correct? And well, this is 2 squared, correct? So this is x minus 1 squared minus 2 plus 2 squared. Okay, well, this expression original here is this one right here. So what I'm going to do is move my expression to this and then to this one. But I have to do something else, the limits of integration. So, okay, I'm going to do the change. When the x is 1, right? When the x is 1, so u equals x minus 1. That's going to be my change, correct? So u is going to be, well, it's going to be 1 minus 1. Because the x is 1, you put a 1 here, 1 minus 1, it's a 0. And when the x is 3, u equals x minus 1 again, so it's 3 minus 1, 2. So for these limits of integration, 1 and 3, the u limits of integration are going to be 0 and 2. So everything is fine, yeah? The u equals x minus 1, the u equals dx, yeah? A equals 2, right? I just all my changes. And then I'm going to change my integral. So this is going to be integral from 1 to 3. So I'm going to have dx at the top. At the bottom, I'm going to have x minus 1 squared plus 2 squared. So remember, I just writing this in this form after all my algebra, correct? And then I'm going to do my u substitution. So this is going to be equals the integral du over u squared minus 1 plus 1 plus 2 squared, sorry. Yeah, and here the situation, 1 and 3 for x, 0 and 2 for u. So you change the 1 by 0, the 3 by 2, remember, by these changes. And then it's okay, well, this antiderivative is right here. So this is 1/2, 1 over a, the arc tangent of u over 2 evaluated from 0 to 2, correct? So it's the antiderivative evaluated at the limits of integration, fundamental theorem. Then I have to do my algebra. So is 1/2 parentheses arc tangent 2 over 2, well, that's a 1, minus the arc tangent of 0 over 2, that's a 0. Okay? Now, the only you have to remember is what is the arctangent of 1? Well, again, my magic table right here. Arctangent, you can see here, arctangent of 0 is 0 and arctangent of 1 is pi over 4. So it's pi over 4 minus 0. And this is going to be 1/2 pi over 4 pi over 8. That's my answer. Okay? So yes, you can see that there's kind of bunch of algebra here, mainly this portion, right? To solve this integral using this as the formula. So to change this into this, I have to do my algebra. And once I change the variable here, I have to change the limits of integration also. So I have my new integral, get the solution, and then evaluate the antiderivative in the limits of integration and get my answer. Okay? Okay, boys? Pretty much the same